Okay, this is review number 3. We're going to do section 1, question 3. We're going to write 1 minus sine squared x over 1 plus cosine x, and that'll equals cosine x, right? Okay. First thing we're going to do is Pythagorean identity, sine squared x, so that'll be 1 minus 1 minus cosine squared x over 1 plus cosine x. And then here we can reference the difference of squares. So if we call 1 a and cosine x b, then we can write a squared minus b squared because there's a negative sign there. Okay, so then it's a minus b times a plus b. Alright, so if we plug that in, so it'll be 1 minus, okay, so then it'd be 1 minus cosine x times 1 plus cosine x, and put all of that over 1 plus cosine x. Put in parentheses just to make it easier for myself. Probably not the right idea though. Anyways, so we can see 1 plus cosine x and then 1 plus cosine x on the numerator and denominator. We can cancel those out actually. So that'll leave us with 1 minus cosine x. Leave it in the parentheses because now we're going to distribute the negative sign, right? Okay, so it's 1 minus 1, right? And then negative cosine x times the negative sign is negative 1, so negative cosine x times negative 1 is positive cosine x. So here 1 minus 1 is 0, so that'll leave us with cosine x, which is what we were going for. So let's box that up, verifying our identity. We got it. We got that one. All right. Section 2, we're doing question 2. So let's get that tangent 5 pi over 12. That is our question. Okay. What I'm going to do is I see that I need to add to get to 5 pi over 12 because we want to work with the unit circle. So we will turn this into tangent alpha plus beta, right? Then let's figure out what our alpha and beta are. So in order to get 5 pi over 12, let's just start going through the unit circle and multiplying it to be over 12. So let's do pi over 6 times 2 times 2, right? And then that'll be 2 pi over 12. And then let's go pi over 4 times 3 times 3, right? And then that'll be 3 pi over 12. And what does that look like? 3 plus 2, that's 5. We don't have to go any further. Let's just use this. So this will equal tangent 3 pi over 12 plus 2 pi over 12. Right? Okay. So we can also plug that in as tangent pi over 4 plus pi over 6. Make it easier for ourselves. All right. I think the next step, not I think, I know, haha, let's figure out what our tangent of these areas are. So if I draw myself a quick little circle here, I can see pi over 4 would be right here, so that would be radical 2 over 2 comma radical 2 over 2, right? And then pi over 6 would be here, and that would be, one second, radical 3 over 2 comma 1 over 2. And then, okay, so we have the unit values, unit circle values. So let's figure out what the tangents of each of these are. So let's start off with pi over 4. So pi over 4, or let's put tangent. Pi over 4 is equal to radical 2 over 2 over radical 2 over 2. So that would be multiplying radical 2 over 2, the reciprocal of this one. So let's put the 2 over radical 2, right? The 2's cancel out because we're multiplying. So that would be radical 2 over radical 2. And that, right here, sorry, we'd have to multiply radical 2 and multiply radical 2 because we can't have a square value in the denominator. Anyways, so it'd be 2 over 2, which is going to equal 1, right? Okay, so our tangent pi over 4 is equal to 1. Let's remember that. Well, we have it here also. Okay, so then tangent pi over 6 is going to equal 1 over 2 over radical 3 over 2. We're going to take the reciprocal of the denominator and multiply it against the numerator. Big words. So 2 over radical 3, cancel out the 2's. That'll equal 1 over radical 3. Can't have a radical in the denominator, so get that out of there. So we'll have radical 3 over 3. And that's our tangent, pi over 6. So, see here, tangent, alpha plus beta. We know sum and difference formula. We can look at, well, this will turn into tangent pi over 4 plus tangent pi over 6, and put that over 1. So it's a positive, so this will be negative because it's the opposite here. Minus tangent pi over 4 times tangent pi over 6. Okay, let's write this here. We're gonna plug in our values, okay? So tangent pi over 4 is 1 plus tangent pi over 6 radical 3 over 3. Sorry. Okay, put that over 1 minus tangent pi over 4 is 1 times radical 3 over 3. Okay, we're gonna write this again over here. Simplify a little bit. We're gonna turn the 1 here, this 1, into 3 over 3 plus radical 3 over 3, just to make it easier for ourselves. We're also going to turn this one here, this one, into 3 over 3 minus 1 times radical 3 over 3. And actually, if we're doing it all in one, let me simplify a step further here. So if it's 1 times radical 3 over 3, that's just going to be radical 3 over 3. Look how nice that looks. Anyways, simplify a little more. Put them over the same numerator, so that's, or denominator. So it's 3 plus radical 3 over 3. And that's going to be 3 minus radical 3 over 3. Next step is to multiply. So take the reciprocal of the denominator. We'll do 3 plus Radical 3 over 3 times 3 over 3 minus radical 3. Sorry. Cancel out these to give ourselves 3 plus radical 3 over 3 minus radical 3. Sorry, I was covering that. But that's... Let me show you some of my work. Okay, we're not done yet. We're going to take this, we're going to multiply it by 3 plus radical 3, and we're going to multiply this by 3 plus radical 3. We want to get this out of there. Okay. It'll happen eventually, but we have to work out this problem. So let's do it step by step. 3 times 3, we'll write it over here, is 9. 3 times 3 is 9. 3 times radical 3 is going to be plus 3 radical 3, right? I'll just keep you over here. Just know that it's there. Okay, next we're going to do radical 3 times 3. So that'll be another plus 3 radical 3. And then lastly, we're going to do radical 3 times radical 3, which is going to be plus 3. Lots of values. We're going to simplify in a moment. Let's do the bottom half. So 3 times 3 is 9. 3 times negative radical 3 is going to be negative 3 radical 3. Radical 3 times 3 is going to be a positive 3 radical 3. And radical 3 times negative radical 3 is going to be negative 3. Simplify this. Let's look at what we have. So we have our radicals and our whole numbers. Let's do the whole numbers first, just keep them in front. So let's look at 9 on the top and 3 on the top. Those are both positive, so we'll add them together to get 12, and add our radicals together to get plus 6 radical 3 over, let's look at our bottom half, 9 minus 3, okay, that's 6, and we have a negative 3 radical 3 and a positive 3 radical 3. Those are going to cancel each other out, so it's just 6. Second step, factor this out. So we have 12 plus 6. Well, let's look at it as big as possible. We can factor out a 6, and it'll give us, factor out the 6, 2 plus radical 3. That's way smaller. Over 6. And look at that. We can cancel out the 6's because they're on top of each other. Okay. That'll leave us with our answer. Our answer of 2 plus radical 3. Make sure to box that, guys. Okay. Long question. One more. Our last one is going to be in terms of, I'll do it way down here. In terms of 0 to 2 pi, we're going to do question 1. I mean, it's the last page, but it's question 1 of cosine 2x equals minus 1, or negative 1. Okay. So our cosine is already isolated. So what we're gonna do is just draw a quick little circle. It's good for my work at least. So in order for cosine 2x to equal negative 1, well, let's think, where does cosine equal negative 1? Cosine is x. This is the x line. Negative 1, it's gonna be right here. Negative 1, comma 0. Okay, and what's our value here? It's going to be pi. right? Because each of the values is 0, pi over 2, pi, and 3 pi over 2, and then 2 pi. We don't need all that, we just need the pi. Our next step here, let's take our 2x, because we figure out the cosine half. So 2x is going to equal pi. It's going to equal pi plus 2k pi. And I know our professor uses pi n or n pi. But I learned this from the video. That's what I've been using. It's what I'm gonna use. So don't freak out if it's n. Okay. I'm gonna put this over 1. I'm gonna put each of these over 1, and it'll make sense in a second. What I'm gonna do is I'm gonna divide out the 2 over here, and see when we do this, we can just multiply the 2 into the bottom half, or into the denominators of each of our values here. So we can take x equals, well, what's 2 times 1? That's 2, so pi over 2 plus 2k pi over 1 times 2 is 2. And then let's simplify a little more. Pi plus 2k pi over 2, just turn into one fraction. We can actually factor out pi here. So if we do pi 1 plus 2 times k, the 1 came from the pi, because 1 times pi is pi, right? So factor that out and it's 1. And then put this over 2. Alright, we have our equation now. So let's plug in some values. So let's set k to be 0. Okay, so pi 1 plus 2 times 0 over 2 is going to equal, well, 2 times 0 is 0, plus 1 is 1, times pi is pi over 2, and that works because remember the 2 pi, and if our denominator is 2, then we're going to go to 4 pi. If it hits 4 pi, we're done. So that works. We're going to set k to equal 1. So we're going to do pi 1 plus 2 times 1 over 2. Okay, so 2 times 1, 2 plus 1 is 3 pi over 2. So we're going to stop at 1 actually, because 3 pi over 2, you go any further, it's past, it doesn't work. So we're going to stop here. And that should be all of the problems. Yeah, I'm done.